Hello everyone. This video is going to cover our very last set of notes in Unit 7, which are similar solids. We talked about similar figures in Unit 6 when we did our SPA chart. And so we are essentially doing the same thing, but now we are doing them with three-dimensional shapes, which means that we get to add on volume as the last part of our SPA chart, and we will now have a SPAV chart. But nothing really changes from the SPA chart to the SPAV chart other than we're adding volume in there. So because of that, I don't really want to have to go over this first section. I will just for funsies, just so that we can kind of see what's going on, but I'm only going to do one of these examples and then we're just going to move on, okay? What do I want to do? Do I want to do cubes or do I want to do cylinders? I want to do cylinders. Okay, so the first thing that they want us to do is find the lateral area, the total area, and the volume of these cylinders. So I'm just going to do a little P, H, and B over here, and then another one over here, P, H, and B. So this will be 6 pi, this will be 6, and this will be 9 pi. And then the perimeter is going to be 8 pi, the height is 8, and this will be 16 pi. Okay, so lateral area is P times H. This is 64 pi. Total area is the lateral area, so 36 plus 2 times the area of the base, which is 9. So this will be 54 pi. And then over here, it's going to be 64 plus 2 times 16, and that's going to be 96 pi. And then volume is big B times H. Big B times H, and that's 128 pi. Okay, so this first column wants us to do the ratio of corresponding parts. So for us, that would be something as simple as saying like the ratios, and then we'll also go and do the heights. So the ratio of the radiuses or the radii would be 3 to 4, okay, which is just 3 to 4. And then if I did the heights, which would be 6 to 8, remember that that's going to simplify to 3 over 4 as well. So no matter what, when you're looking at the dimensions of your shapes, you end up with the same ratio, 3 to 4 in this case. The next column is going to want us to find the ratio of lateral areas. So this is just our areas. So this will be, our areas are 36 pi and 64 pi. So 36 pi over 64 pi. When I simplify that, you get 9 over 16. The pi's cancel, you get 9 over 16, which if you recall when we did the SPA chart last, area is always your S&P, your dimensions, values squared. So 3 squared is 9, and then 4 squared is 16. The next column wants us to do the ratio of surface area or total area. So that's going to be 54 pi over 96 pi. This should again get us 9 over 16, but I am still going to double check just to make sure that I did my math right. It does give us 9 over 16. So again, our area is still 9 over 16. And then the last thing it wants us to check is our volume ratio, which will be 54 over 128. So 54 pi over 128 pi gets us 27 over 64. Now what I really want us to do is check out how our side ratio or our dimension ratio corresponds to our volume ratio. And if you look, 3 to the third power is 27 and 4 to the third power is 64. So anytime that we have an area, it's our side length squared, and then anytime that we've got our volume, it's our side lengths cubed. Okay? I don't really care about all that. So here's what we're going to do. We now have a SPAV chart. So we're just adding on a third value there, which is volume. So remember that your ratio of areas is always going to be squared, and your ratio of volumes is always going to be something to the third power. So I am going to move this way in my table. 1/3 squared would get me 1/9. And then 1/3 to the third power would get me 1 over 27. So that's how that would work. Now, in order for us to do this, we always need to know our ratio of corresponding parts. So in my second example, I actually have to go backwards to get my ratio of corresponding parts in order for me to find my volume ratio. So this will end up being 6 over 7, because remember that if I go this way, it's got to be 6 squared and 7 squared. So when I go backwards, I'm square rooting everything. So the square root of 36 is 6 and the square root of 49 is 7. Now that I know that, I have to take both of these numbers and I have to cube them to get my ratio of volumes. So 6 cubed is 216. And then 7 cubed is 343. And then lastly, I've got 64 over 125. I've got to go this way, which means that I have to cube root each of those things. Remember that you can get the cubed root by going to math in your calculator and going to the fourth option. So the cubed root of 64 is 4. And then I think this is 5, but I'm going to check it anyways, just to check. 125 is 5. So this will be 4 over 5. And now that I know what the side length ratio is, or the corresponding parts ratio, I can square that to get my ratio of areas. Okay, so there we go. All right, so now we're just going to start trucking through this. It says the lateral areas of two similar cones are 100 pi and 25 pi. The volume of the smaller cone is 40 pi. Find the volume of the larger cone. So because these are similar solids, it tells us that they're similar right here. I'm going to set up my SPOV chart. Now, when you're looking at the area column, it doesn't matter if it's a lateral area or surface area. If they give you any kind of area, it goes in the area column. So they gave us two areas. They gave us 100 pi and they gave us 25 pi. Now, as a reminder, whenever we are working with our SPA chart or our SPOV chart, we cannot have unsimplified items in this chart. So this will simplify to give us 4 over 1. So now that I know that my area ratio is a 4-to-1 ratio, I have to go backwards to get the S&P ratio, which will be a 2-to-1 ratio. And then I got to go all the way this way to get my volume ratio, which should be an 8-to-1 ratio. Okay. Now, it gave me the volume of the smaller cone. Find the volume of the larger cone. So because it's asking me for volume, I need the volume ratio. They gave me the volume of the smaller cone, so that's going to go with the smaller value here. And now I've got to find the volume of the larger cone. So this is going to be 40 times 8 divided by 1. Whoops. 40 times 8 divided by 1 is going to get me 320 pi centimeters cubed. So we still use our SPOV chart the same way we used our SPA chart. Okay. All right, number 2, it says the volumes of two proportional prisms are 200 centimeters cubed and 25 centimeters cubed. So I'm going to go ahead and drop my SPOV chart in here. It gave me the volumes this time, so I've got 200 over 25. I've got to simplify that. 200 over 25 gets me 8 over 1. Now I've got to remember, go all the way over here to get my S&P, and then I just go over here to my area, which is a 4-to-1. Okay, so it says the lateral area of the smaller prism is 15. Find the lateral area of the larger prism. So here's my area ratio. It said the lateral area of the smaller prism is 15. Find the lateral area of the larger. I think that's 60. So X will be 60 centimeters squared because it's looking for area. Number 3, a cone-shaped pile of sand weighs 400 pounds. How much does a similarly shaped pile of sand weigh if each dimension is 4 times as large? So we are going from a 1-to-4 ratio when we talk about the dimensions of these cone-shaped piles of sand. So if it's 4 times as large, I'm going from a 1 to a 4, which means my area would be 1 to 16. And then this would be a 1 to 64. So I just get to move straight across my SPOV chart. Now it's talking about weight, which means that we're going to be looking at volume. So I'm going to grab my volume ratio. All right, it says a cone-shaped pile of sand weighs 400 pounds. How much does a similarly shaped pile of sand weigh if each dimension is 4 times as large? So I am getting way bigger with this. So we're going to do 400 times 64, and that gets me 25,600 pounds. Oof. It's very heavy. Oh gosh. Go away. Okay. Number 4, a brick of peat moss weighs 45 pounds. How much does a similarly shaped brick of peat moss weigh if each dimension is 1/3 as large? Okay. So now we're getting smaller, which is fine. If it's 1/3 as large, we can still do a 1/3 ratio. We just need to make sure that we know that this was our original size, and then our new size is going to be the 1. It doesn't matter. You can also do 3/1 since it's getting smaller. It really doesn't matter. So this will be a 1 to 9, and this will be a 1 to 27. Again, we're dealing with weight, so we're going to go with volume. Now it says a brick of peat moss weighs 45 pounds. How much does a similarly shaped brick of peat moss weigh if each dimension is 1/3 as large? So we're getting smaller, which means that my original is going to have to go on the bottom. So 45 times 1 divided by 27 gets me something disgusting. That's going to be... This doesn't give me something very nice, which is fine. I'm just double checking to make sure I did this right. Okay. Is 1/3 as large. So 3 to the third is 27. Okay, so I'm not crazy. And that was my original, so it should be getting smaller. Okay, so 45 divided by 27. It weighs approximately 1.6 or 5/3 pounds. Right, math and yeah, 5/3, okay. Okay, I am going to stop there just because it's the same thing over and over and over again. I will finish the last 2 problems on these notes, on the completed notes, but that is essentially all you have to know about 7-7. If you have any questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye!